We have this question to solve. If one root of the equation x squared minus px plus q equals 0 be twice the other, then show that 2p squared equals to 9q. Now we are given this equation, that is quadratic equation, x squared minus px plus q equals to 0. And we are told that one root is twice the other. And the letters that are commonly used to denoting the root of quadratic equation, they are alpha and beta, which are Greek letters. So that is, we have let alpha and beta being the roots of the equation we are given, the equation. So that is, we have general form of quadratic equation. So recall that general form of quadratic equation is ax squared plus bx plus c equals to 0, where a, b, and c are constant, where x is the variable. Now when we compare these two equations together, so that is the given equation with general form of quadratic equation, we have this to be x squared minus px plus q equals 0. It implies that when you compare in this equation now, we have a to be 1 here. A equals to 1. Now b to this equation, now b represents the coefficient of x. So therefore b equals to minus p. And c is the constant. C equals to q. Now the sum of the roots of quadratic equation, sum of roots. So I've made video on this, that is alpha plus beta, because we are denoting the root to be alpha and beta now. Sum of the root equals to this, that is we have minus b over a. And in this case, we have a to be 1 and b to be minus p. So substituting here, we have minus, open bracket, because here we have minus and b is minus p. Substituting minus p for b. So in place of b, we substitute minus p. Then in place of a, we use 1 there. So when you simplify, you are going to have minus by minus will be plus. We have p over 1, which is equal to p. So equals p. Now, we want to determine the product of the roots. Product of roots. So that is, we have alpha beta equals to, that is the given root now. So alpha beta, the product of the root, has a formula using these letters a, b, c. So that is, we have c over a. So that's the formula we are using there. So therefore c is q, then a equals to 1. So when you substitute, you have c, which is q, divided by 1, which implies alpha beta equals to q, that is q over 1. So we have this sum of the roots, that is alpha plus beta to be p and alpha beta to be q. Now don't forget the information we are given from this question, that is we can take alpha to be 2 beta, because one root is twice the other, or the other way around, we can take beta to be 2 alpha. So we get the same thing. Now let's take alpha equals 2 beta. That is, whenever you see alpha, you put 2 beta there and you leave beta as beta. So coming to this, so let's label this equation alpha beta plus beta equals to p. So label this one to be equation 1. Now substitute, whenever you see alpha, put 2 beta there. We have 2 beta plus beta equals to p, which implies, so when you add 2 beta and beta together, you are going to have 3 beta, which is equals to p. So label this one equation, let this be equation 3, equation 2 here, then we have equation 3. So now in equation 2, we have alpha beta equals to q in equation 2. Now don't forget alpha equals to 2 beta. Now we are going to substitute wherever because in the first equation that we substituted for, we use 2 beta for alpha. In this equation 2, we are going to do the same thing. That is 2 beta, whenever you see alpha, you put 2 beta there. So this implies we have 2 beta multiplied by beta equals to q. That is, we substituted 2 beta for alpha. So therefore, when you open bracket here, you are going to have, this implies 2 beta squared equals to q. That is, when you multiply these two together, you are going to have this. Now call this one equation 4. So now we are going to eliminate b, or we can substitute. Let's substitute for b from equation 3 now. From equation 3, from 3, we have 3 beta equals to P. Divide both sides by 3. So it implies that beta equals to P over 3, which implies we are going to substitute label this on equation 5. We substitute equation 5 to equation 4 to prove what we are required. We are required to prove that 2P squared equals to 9Q. Now, whenever you see beta in equation 4, you substitute P over 3 from equation 5. So therefore, we have 2 into beta is P over 3. We have P over 3, then raised to power 2 equals to Q. When you simplify further, you are going to have 2P squared will be P squared, that is P by P, then 3 squared will be 9. So equals to Q. And when you cross multiply here, it implies that 2P squared, then 9 by Q will give us 9Q. So this is what we are required to prove. And it has been proved, or it has been shown as required. That this we have shown as required. This is what we are required to show, and it has been shown. So this is the solution, or the answer to the question we are given to solve. If you have any question, you can drop in the comment section. Please don't forget to like, comment, and share. Thank you.